Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Log4J Tales from the Trenches, the state of Log4J remediation, brought to you by WhiteSource. We have a great webinar for you today, but before we get started, I need to go through some quick housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the on-demand for viewing. My apologies. We'll be sending out a link to access the webinar on demand, or you can visit devops.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. And joining me today is Reese Arkins, Director of Product Management at WhiteSource, and Sela Pinto, Director of Software Engineering, also at WhiteSource. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Hi, everybody. Nice to meet you. So just before we start, I would like to ask you a question. And my question is, where were you when the news broke with the Log4Shell vulnerability? Take 10 seconds to think about it, and then we can start. So today, we will we would like to share with you how did we handle the Log4Shell vulnerability. We have this special angle because we both develop in Java and we experience the same, this exercise in our code too, but we also have our customers and that we have to give the solution to them. And again, Reese would eventually share upgrade and the detection and remediation practical tools and advice to keep rolling this activity. So going back to this December 10th, 2021, you can see it was actually Friday. That was the day that the CVE was published. And we actually, our R&D group located in Israel, which is a weekend. So Friday in Israel is the weekend. So we were basically preparing for the weekend, most of us. And specifically and maybe symbolically, while the fire of Log4j started outside, I was starting the fire in my backyard. Now let me tell you this. Vulnerabilities are published during weekends and published all the time. And we can't just go, even theoretically it's possible. Practically, we're not going and patch all over the place over and over again. Organizations and companies has the tolerance for vulnerabilities to exist for sometimes in their code. It's actually about a risk management approach. Okay, we would like to manage the way that we handle our vulnerability management. So in this situation, when we know that there is something going on about the Log4j, there are three questions that we want to ask ourselves. First one is, how severe is this vulnerability? What is the damage, the potential damage it could do to my data, to my code, to my customers? The second one is how exploitable it is. The fact that it's theoretically severe doesn't mean that practically it could be exploited in my specific configuration and in my specific environment. And the third thing is how common it is. What are the chances that it's actually will ended up existing in my code or in my environment? So, Reese, I would like to ask you, how did you experience this vulnerability while doing your risk assessment?
Yeah, hi, Sailor, thanks. So yeah, it may not have been a weekend, but urgent problems on a Friday are also not appreciated in most parts of the world, so I remember it quite well. This one was special. There's a reason why we are talking about it. As you say, vulnerabilities happen a lot, and they do happen on weekends. And in general, people in the business of risk management So it doesn't mean you have to react to absolutely everything. This was one that deserved people's attention. In terms of how severe it is, as people joining probably are aware, I mean, what this enabled was, remote command execution. So this means that this is pretty much the worst you can get, because if someone can execute commands from remotely, it means that they can pretty much take over anything and potentially use it to leapfrog. So severity was very high. Exploitability was unfortunately also extremely high, and that was because all that was needed was for a user provided string to be logged. As long as the attacker could get a string logged in any way by Log4j that matched what they wanted, they could be successful at it. So that in that case, it was extremely exploitable. We often have vulnerabilities about, you see things like about SQL injection and things like that, and you often have to go back and trace through whether it is exploitable. It means, can someone really craft a string that gets all the way from their browser or however they access the app, all the way through to the database, or is there some, an impossibility? So, for example, it's the first name field that's limited to 20 characters or something like that, and you couldn't possibly do it. But in this case, it was completely exploitable. And then common, it was incredibly common. We're going to talk about that soon, the statistics. But like as an example, Sal and I, we work, in case you're new to WhiteSource webinars, we work in open source security. That's what we do. And I don't probably speak for everyone at WhiteSource, but it's not like the most exciting thing for, a dinner party conversation. People ask what I do. IT, computers, software, that type of stuff. But for example, my wife that does not work in open source security asked me about it. Have you heard about this thing, this really big security thing going on? I'm like, oh yeah, that's what I was working on yesterday, And even like my friends in Australia, who I still keep in touch with chats and stuff, we're talking about it. So it was almost the most well-known open source security event ever, I would say. So this one ticked every one of these boxes.
Right. So this one is bad and it's real. It's actually for you attackers, if you would like to try a vulnerability, because just like Reese said, it's serious. The remote code execution is the serious as it could go. The countless servers are vulnerable, and it was so easy to exploit. All you have to do is to send the string, the special string in the special format. So we had a problem. I mean, for the risk evaluation, we understood that there is a risk here. And of course, it's a weekend, but even if it wasn't, there was things to do, and immediately. So the first thing we did immediately is a mitigation of configuration. Okay, the first thing you want to do when there's a fire set outside, you want to hold it. You want to hold the fire. Is specifically here the network. So the first thing we did is to configure the web application firewall and start to block and to manage the requests. There are several configurations that are possible here. I gave just example of a few of them. So you could actually configure your network based on the content of the input, by the origin of the requests, or by the size of them. So those are the rules that we configured. And there are more things that you can do, specifically if you have the Log4j, like remove the JNDI lookup class from the class path and some more of it. But really doing this for a start, it's a mitigation. And the first thing you do to try to hold the fire back. And actually, lucky us or not lucky, we saw that not while after we actually initiated those configuration and this mitigation, so we actually start seeing attacks. So happily, the attackers were quick, but we were quickers in this case. Okay, so we did a configuration thing, and now we can breathe and move on to detection and start to analyze our code and see what we can patch and how can we patch it. So we're working on a Java. I mentioned that we're working on a Java project. So we have our project and we have dependencies. We're using Maven for that. Now, while locating the vulnerable packages in the direct dependencies is pretty simple. It's pretty simple, I think, to do. Doing this for your transitive ones might be trickier, right? Because we can think about it like the tip of the iceberg, because it's very available. Like you could do a text search to find your direct dependencies, probably by looking in your manifest file or POM file. But what about everything you don't see? What about your other dependencies that has the other dependencies that pull on other dependency, and so on and so forth? So, Reese, what do you think about this iceberg slide?
Yeah, I mean, it's somewhat of a cliche, but it's my favorite cliche when it comes to talking about open source in general. So we like the iceberg analogy because it does represent kind of two things. One is that the volume of transitive dependencies is typically like that iceberg below the surface. It is, say, 80 or more % of the total dependencies. It can sometimes be far exceeding 90%. So that's part one, because people often don't grasp just how many transitive dependencies there are, because they judge it based upon the number of direct. The other reason why the analogy works really well is that it's this idea that it's also what you don't see. And that is especially true with transitive dependencies, and even more especially true in the Java world, because log files are so infrequently used. And it means that people just see their direct dependencies, and unless they go manually inspecting things, they generally aren't going to see just how many or what transitive dependencies they're using. So this analogy definitely works really well, and it also it generally applies to security as well. So on average, we see around 80% of all vulnerabilities detected in our customers' code, regardless of language, are in transit dependencies.
Right. So, lucky us, we work at WhiteSource, and that's what we do, the software composition analysis. We didn't have to go and rescan the code or build it. We actually had it all ready in place. And all you have to do is make sure that the vulnerabilities and all the data exist in the databases, of course, for us and for our customers. And then we just had to go and take a look at our repository and see what's going on there. So that was a great thing, a great relief that we had, because we knew that our code is well managed in advance. Okay, so what about a third-party product? After we did the configuration and after we did the direct dependencies and the transitive dependencies, we still have low control on the third-party products that we use. I mean, we use it everywhere. Either it's the AWS or Azure platform, the logging services, CRM, workflow management, or code management, etc. So unfortunately, we don't have like the magic solution there or the magic platform there. Usually vendors just share their status and the risk analysis. And the best thing you could do, or we did, is to go and update in the advisories and update the status and try and keep tracking that part of the code. So to sum it up, the remediation race, when that's a kind of a vulnerability in such a scale were published. So the first thing you do is you hold a fire using the configuration, and then you do the direct dependencies, which you have the best visibility and the control. Now, the transitive dependencies, you have less visibility and less control, so it's that's the next thing. And then the third-party products, which you have probably almost no control and probably almost no visibility, but a continuous monitoring and see where you stand and if you're still vulnerable or not. I mean, that's part of the thing. It's not something that we did it and that's all. That there are still open source components that were not upgraded, and we would have to continue and monitoring and see an update where we're standing there. So how did the industry manage the Log4Shell? So again, I mentioned at the first that I'm director of R&D of the knowledge group. So actually all the knowledge of WhiteSource is gathered in our group, in our databases. And besides sharing all this data with our customers, helping them keep their code more secure, we have a lot of insights that we can tell and share about the state of our customers, but also of the industry itself. So we know that Log4j is extremely popular. There are more than 35,000 of Maven library that were vulnerable, but each one of them has different versions. So eventually it came across about 150,000 Maven packages that's vulnerable to this to Log4Shell. About 70% of all Java businesses were impacted, taking into consideration their code and their dependencies. If you take the consideration of the third-party products, it could get to even more than that. 30% of the alerts came from indirect packages, which means that even if you know your code, and you're up to date with it and you know exactly what you have, there's still a big chance, about 30%, that you will have this vulnerability coming from your transitive dependencies, not from your direct dependency. And about 24% of the packages have available fix. Packages meaning the open source packages in Maven. So just about 24% of them still have available fix. Currently have available fix, which is actually low number risk, isn't it?
Yeah, it's definitely a low number, although there is a reasonable amount of explanation why that is. If we go back to the previous figure, 30% of the projects were indirect. That's the transitive dependencies, the below the iceberg. As I mentioned earlier, that normally around 80% of vulnerabilities that we find are in transitive dependencies, and so here you see it's 30%. Although Log4j was the big one, and it was terrible, there was something about it that in a way saved us from it being even worse. And that is that the way Log4j is used, because logging is generally an app concept, not a library concept. So if you think that you pull in libraries into your application and you use them, generally you'll do application logging. You'll write your logs and not your libraries. And the reason for that is that if all your libraries just went and logged in their own format using their own library, and you had to be trained to track that, like some are using like JSON format and some are just logging plain text. So in general, libraries don't log, or at least the libraries that people use don't log. And that was a big saving here, because what it meant was packages that you would import as your dependencies were less likely to import, other libraries, which, and use Log4j in that sense. So that the 30% figure is an important one to start with, and to realize that we actually got lucky, because there can be libraries which are more commonly used that are used instead of like a logging, which is generally only for applications. So that then partly explains that 24%. So that is 24% of the open source packages that we cover. And so that is explained. For example, a lot of those, that 100% would be like applications that people publish to, say, to GitHub and then to like Maven Central. A lot of time, the way we think about things is that we look at open source. There's a lot of like very popular and well-maintained libraries, but there aren't as many popular and well-maintained applications. Like a lot of the applications you find, whether it's on NPM, GitHub, Maven Central, they're kind of someone's like school project, toy projects, or some project they've abandoned. So out of that 76% that don't have a fix, there'd be a lot of those where it's just some project someone wrote with no intention that it's really used by anyone. There would be packages which are now like deprecated and no longer used, and the person doesn't want to go to the effort. And then you would maybe have some where there is no ability to log user input. So people have looked at it and said, yeah, I use Log4j, but no external person, no attacker can log, can get a string into the logging. So we call that an ineffective or an unreachable vulnerability. So those different use cases have added together. There's definitely still a significant portion of that 76% that will need to be fixed, that should be fixed. But there's a pretty high amount, probably exceeding 50%, that will never be fixed.
Right. But I mean, it's extremely important to keep tracking and see how your project is still exposed or not exposed to those fixes that yet to become. Okay, and what if I'm not using Java? I mean, I heard many people say, okay, so we're using other libraries, so we're lucky we got out of it. So an interesting POC that we managed to do actually talks about Ruby. I mean, there are other languages that run on the JVM that could also be exposed to that vulnerability. Specifically, we did find this vulnerability in some Ruby packages. There's still possibility that they're existing there in some other languages or other languages that run on the JVM. It's really recommended to go and read it and actually follow the POC and educate yourself with that Ruby. And let's move on to detection and remediation. So what can we do next on our code base for our listeners?
All right, thanks, Sarah. Okay, so I enjoyed that advice, Sal. I hope you did too. Part of the idea of this webinar was that as WhiteSource, as both a victim as well as a vendor in this, that we could give a reflection from multiple angles. So we were affected. We used Log4J in some of our applications, but at the same time, we had thousands of customers urgently wanting our help and guidance and things like that. So our goal in this webinar, as well as in other things we're putting out, is to try to kind of improve for next time, hopefully have people, customers especially, be ready for it if there is a next one. And I will end today with a good news case study or success story from one of our customers. All right, so in this next section, I'm going to discuss a little bit more on the direct dependencies versus those indirect or transitive, but also focus particularly on manual scanning and remediation as compared to automated scanning and automated remediation. So what we found is that a lot of companies were having to handle this problem with non-automated means, like manually scanning project after project, manually fixing them. Sal has been using the fire analogy, so I'll say that's a little bit like like a wet newspaper trying to put out the fire. When you have hundreds, thousands, or even more projects, you ideally need to have an automated way to detect, as well as an automated way to remediate. And both parts are important. At WhiteSource, we consider ourselves to be a remediation-centric company. What that means is that, if we've got the choice of being able to, fix 5 additional problems or find 5 additional more problems, we generally err on the side of fixing them, because a problem unsolved still remains to be a problem. So that's what we refer to as remediation. All right, so now let's talk about the detection part. There is a saying I like from Muhammad Ali, where he used to say that your hands can't hit what your eyes can't see, right? So we can't remediate something that we don't know we have. We can't remediate something that we're not aware of. So in order of complexity for detection, knowing that you have a problem, direct dependencies are by far and away the easiest ones. For an example, with Maven, we can go and look in the pom.xml file. It's right there in the repository. You can literally just, say search your GitHub, your GitLab, or whatever, and see there's Log4J, find the version, update it. It's still manual, but it's fairly easy. In next order of complexity, the next easiest way to find dependencies or problems with dependencies is when you have a log file. Because the whole nature of a log file will mean that it's checked into the repository, and therefore, again, it's searchable. So it may not be intended to be human readable. It's somewhat human understandable. So again, you could kind of search repositories and find. Now, the bad news is in the Java ecosystem, Lock files here are pretty uncommon. So I'm pretty much going to just neglect them for the rest here because it's more of an edge case than a real one. What we found for people using Maven, people using Gradle, was generally that there is a lack of lock files. And so therefore, the hardest is the transitive dependencies without a lock file. As Sela said earlier, they're kind of like the hardest to detect, and they're the hardest to find, and they're the hardest to control. Because even when you know that you have a problem in a transit dependency, you can't just go and patch that so easy or force its version if it has a parent dependency you're using that is not updated yet. Right. So when it came to manually detecting Log4j, as I said, direct dependencies, you can look in your pom.xml if you're using Maven. Gradle can be a little bit more difficult because, Gradle can have groovy Kotlin scripting, and I've seen people have quite complicated ways of pulling in versions. So for example, if you're using Log4j API, Log4j core, you might define a variable off in one file that says var, L4j version equals 2.10.0, and then it may be a little bit harder to find than if you just define them directly. One of the good things or great things that Gradle has done recently in the version 7 is introduce a concept of a version catalog, which is essentially a centralized location where you can define your dependencies. No doubt anybody who had adopted that model would have found it a lot easier to locate Log4j if they were doing that manually. So then we get to that harder one, transitive dependencies without a log file. This one's not easy. If you're doing this manually, then the process would be approximately, you would need to clone the project locally. You'd need to check it out. So you've got a copy of the code. You need to run the manager install. You'd need to run Maven install or run Gradle in order to download all of the dependencies. And then finally, you'd need to inspect the installed packages. You can do that manually sometimes, or there can be a suitable command. So for example, with Maven, I'll show this soon, there's a concept of Maven dependency list, Maven dependency tree. But essentially, this is the way that you would need to detect things manually. And of course, you can't be sure that you don't have transitive dependencies in the first place. So you generally can't be sure that even if you found it directly, that you don't need to do the second step. So if you imagine this for people having to do this at scale and do this manually, including the potential for human error, this is not a great way to know if you are vulnerable. So one of the things, at WhiteSource, we have a lot of commercial and enterprise solutions for open source security, but obviously Log4j was a big event. And we did some brainstorming about ways in which we could help the industry in general with free tools in this case. And so one of those tools that we released, we called Log4j Detect. So I'm calling this one semi-automated transitive detection. It's semi-automated because ultimately you still got to kind of run it. You still got to orchestrate it somewhat, but it automates the process of telling you not only if you have Log4j transitively, but also to confirming if the version is vulnerable and recommending the best non-vulnerable version. And if you were involved in this Log4j catastrophe, you probably would have been aware that on multiple days, the recommended fix kept changing because people found more problems in Log4j. So the way that Log4j Detect automates the process of finding transitive Log4j, so it will detect if you're using Maven or Gradle within the project, including subfolders. It will identify all installed dependencies and confirm if a vulnerable Log4j is found. It then identifies the dependency paths through which Log4j is installed. So instead of just telling you, yeah, you've got Log4j there, good luck fixing it, it will tell you all of the paths through which you got Log4j. So for those people that do have it transitively, it'll help you understand that transitive path. And finally, it recommends a non-vulnerable Log4j version to update to, which, like I said, is handy because it can be hard to keep up with the latest thing. Okay, so this is an open source project, by the way. I said free before, but actually it's open source. So MIT license, you can take it, extend it, use it, fork it, whatever you want. So it's available on GitHub, WhiteSource/Log4J detect distribution, and we do make updates to that as necessary. It seems we've had a bit of thankfully, a period of no new CVEs in Log4j. Sela, I think it's about 2 weeks now. Is that right?
Yeah. Wait.
Yeah. So hopefully it's now settled down. So the tool is available on GitHub. It has download and installation instructions. Essentially, you can, if you're using a shell, you can curl it, things like that. Let's see it. So now I'm going to compare it to the kind of fully manual ways, to this kind of semi-automated way. And then after that, I'm going to talk about the fully automated ways in which companies were able to detect and remediate Log4j. So first of all, if we look here, I picked a project called SPDX Maven plugin. This one is a tool for generating certain format of files based upon dependencies and things like that. And I picked it because it had a transitive vulnerability. And more than a week after the critical nature of Log4j was known, it still hadn't had a fix. So it was indication that the fix wasn't fully trivial, as an example. So we look here, I've checked this project out locally. Remember I said before, you have to clone it. You can see, you look at it, ls-l, I've got a list of files. So, I mean, there's nothing here, of course, that says Log4j. But to make things a little bit more confusing, if I ran a grep command, which is essentially like search all files, I ran a grep command in this checked out repository. There's multiple hits for Log4j. You can see here, though, the files that it's in, it's like SPDX tools, POM file example XML. So, okay, it's an example file, so I probably don't need to worry about this, right? But still, in the heat of the moment, when you have to make these types of judgments and assessments, it just slows you down. So I'm trying to illustrate here, the difficulty and the fraught nature of manually trying to fix things. We also see under source, but it's under source test, that there is an instance of Log4j, in an XML file there. So again, it poses this question of, is that it? Do I need to change that or not? Now, the short answer is no, actually. Neither of those things actually would make you vulnerable, but they will slow you down when you're trying to manually work things out. So as I mentioned, the next step you want to do is a Maven install. So this is the kind of the tail end of a NVM install. It worked, it's all set up, and Maven does come with a concept of Maven dependency tree. So that's actually a good thing about Maven, that we could do that. So ran a command here, Maven dependency tree includes Org Apache logging, Log4j, Log4j. Remembering that, again, I've had to make like a judgment call about, is it only Log4j core that's affected, or do I need to be worried about other Log4js, because you can get other ones. And Sailor, you'd remember this one well. I mean, even within WhiteSource in those early kind of hours, there was confusion. Like, is the Log4j API affected? Are wrappers affected? And things like that. So trying to make this call and run commands manually is generally not a great idea. But this is how you'd do it if you did it. You can see here in the middle of this kind of screenshot that the Log4j appears. You can see that it is indeed a transitive dependency. It comes through org SPDX tools, which is kind of like a sibling package to this SPDX Maven plugin. It also answers the question of, why is this library or tool, how come it has transitive Log4j when I said earlier that generally libraries don't log? And the answer is that this is really like a plugin. This is a wrapper around another library that does log, and so it's intended that transitive one does. So if we were doing things completely manually, I would have now found out that I do in fact have a vulnerable Log4j. I need to make a decision about, do I think that an attacker could somehow access this and force me to log things or not? So for example, maybe I'm logging lists of dependencies, and maybe someone intentionally has a dependency that includes the JNDI stream, something like that. So this would be where you would be at after one project with manually doing it. All right. So now I'm going to demonstrate how the Log4j detect improved that. So even if you're doing things manually, this kind of semi-automated way. So in this case, I ran Log4j detect scan, and then in the local directory. And what we can find is that it confirmed to me in a slightly nicer format the vulnerable paths. So you can see here that Log4j core is actually found through two different paths, not only one. And it also confirms to me that it's vulnerable. So again, that reduces the chance that there is kind of human error in that. It provides links to learn more, it provides recommended steps and so on. So this is just like a slightly more efficient, nicer way of wrapping those, like Maven, Gradle, and I believe Bundler. Sally mentioned earlier that we'd found some cases where some bundler libraries are actually, I'm saying bundling, but bundling in Log4j through like a JVM type approach. So our tool actually does support Gradle, Maven, and the cases where we found bundling. Okay, so let's move on to automated detection, because realistically, I think if there's anything people learn from this Log4j is that automation is. So let's again start with detection. You can't remediate what you can't see. So if we talk about automated vulnerability detection, I start with the good approach. So a good approach would be that you run a scan on every commit, and if a problem is found, such as vulnerable Log4j, it raises issues or alerts. It could be Slack messages, could be Jira issues, could be GitHub issues, that type of stuff. This would be a good solution. So every time a commit is made, you run. If there's a problem, you generate some type of alert. When people learn about automated open source security solutions like WhiteSources, this is in fact what most people assume is how it works. But it's actually not the best way to do it. What's better is running the scan on every commit, but remembering that manifest, or that SBOM, sometimes people might call it. That's a key part. Because remember, not every project gets commits regularly. And if you think about Log4j and that need people had to remediate it within ideally hours or days, and hey, it was a weekend. So if you've got a project, even an active project that you generally don't commit to on weekends, if you were relying on your automated solution that it only would run when you scan things, meaning that you had to wait for a commit, you would have been far behind. So instead, you need some state. You need a solution that remembers what your manifest is. It remembers what your dependencies are. And then at any time in the future, when new problems are found, those problems are cross-referenced against what it remembered about the dependencies that you're using, and you are then alerted if any pre-existing manifests are affected. So for example, with us at WhiteSource, as again, both affected and trying to help people, what happened was we accelerated the entry into our database for Log4j as soon as we realized what was happening. And that started triggering a number, like thousands and thousands of alerts, both to us, a small percentage to us because we were using it, as well as to our customers. It didn't require us or our customers to be, taking action on a Friday night or whenever it was that they heard about it, because even if they hadn't scanned a project for 6 months, we still knew that if you're using a Log4j, then it's effective. I did want to highlight though some of the kind of the free tools and stuff that we do provide. And for example, WhiteSource Bolt. This is something we've had for years, and this is a free offering that we have. It's on, I'm showing GitHub here today, but we also have an offering for Azure DevOps as well. And we're planning to expand it to other platforms in 2022. So here's an example of automated vulnerability detection for free using WhiteSource Bolt. Now, I've used that same library that I showed before, that SPDX Maven plugin. And you can see here the type of alert that we get. So it's got the CVE number, But importantly, it tells you it's a high severity vulnerability. It tells you the library, like Log4J core 2.10.0. And then it also tells you how you got it. So it shows that it came through the SPDX tools 222, and that's how the Log4J core 2.10.0 was found. Now, for example, both GitHub and GitLab have quite great free dependency scanning solutions, but neither of them would find this type of scenario because they scan the direct dependencies or transit dependencies if there's a log file in place. So in this case, people who had transit dependencies in Maven or in Gradle would not have got an alert from like traditional scanning. They would not have been aware. They would have needed to have gone and done it manually. WhiteSource Bolt, though, it behaves a little bit like we discussed before. In the background, it will go and it will check out the repository. It will run Maven install, and then it will generate a tree, and it will remember that. And that's how you can get an alert for the indirect or transit dependencies. So people that used WhiteSource Bolt or used WhiteSource Commercial Solutions started getting a lot of these types of alerts. They would have had alerts by email, alerts in our application. If enabled, GitHub issues. We have Jira two-way sync and things like that. So at this point with automation, within hours of the kind of event being known, people started getting alerts to the fact that there was a problem. They didn't need to wait for, Monday when someone scanned or things like that. So, detection, alerting, those are really key facts or key important things to do. The next step is, of course, remediation, where again, automated is best if you can do it. So in this case, we also have more free offerings. Again, everything I talk about here free is available for commercial, but I wanted to share with things that you can adopt maybe for the next time. So Renovate Bot is an open source tool by WhiteSource. It is in the business not of necessarily vulnerability management, but dependency automation. It's a popular tool. We hit 7,000 stars this week on GitHub. There's more than 500 contributors. And its goal is to be cross-platform, cross-language dependency automation, as well as the open source, which supports GitHub, GitLab, Bitbucket, Azure DevOps, and Gitty. It also has a free hosted app from github.com. So its purpose is to keep dependencies up to date. And that includes DevOps and infrastructure as code, like Kubernetes manifests. There is enterprise version support available by WhiteSource as well, of course. So Renovate Bot is in the business of dependency automation, but of course most people have a lot of dependencies that are out of date. People might have, say, 20 dependencies which are pending an update, and so we don't want those to get kind of lost in the we don't want that to get lost in the noise. So we have a special category of update, which is the vulnerability remediation. Sorry, Sally, do you have something to add now or later?
No, I just thinking it's a really amazing solution, and it was a great experience taking part of it and actually index all the dependencies in advance of Maven in advance, so we could actually do that on enable that. I mean, I think it's one of the really biggest wins of this crisis.
Yeah, so what Sal's referring to is what I went back mistakenly is our Log4J remediations. So Renovate is a very extensible tool, and it has the ability for presets. And so when we were brainstorming, this actually was literally our CEO. We were having daily sessions to make sure that we were handling our own problems, our customer problems. And he said, we're a remediation company. How can we help people remediate? We were looking at the statistics about what % of projects are fixed, including our customers. What can we do? And so one of the ideas we had was that problem before of transitive, that's one of the barriers people have. And so we worked out that if we could have basically some predefined rules of all known transitive fixes available, so that 24% that do have a fix we talked about, if we can take a lot of those and make that kind of freely available, that this can help. So Log4J remediations is a second repository. Barry, thank you for posting the link in the chat for the first one. Maybe you could help me out here with this one if you don't want to click on it. Log4j remediations is what we call a set of preset rules. And it can be used in the free and open source Renovate tool. It's not commercial, it's not paid for. And it contains rules for over 1,000 like well-used packages which use Log4j transitively. So again, instead of people getting merely automated notifications and having to do the work how to fix it, this would help them go one step further and get automated fixes. In order to use it, for example, you either could self-host, as I said, it's open source, but if you're on github.com, you can install the app. You add this preset URL, this GitHub WhiteSource Log4j remediations. You can see it in the screenshot to the right. And what this will do is automatically superpower your Renovate to know about the 1,000+ packages and their automated fixes. And again, using the project that I had before as example, the XPDX tools, you can see here there was a pull request, update dependency org XPDX tools to version 227. So that is the version which has the fixed version of Log4j. So you can see here that there is a heading here. It says security to catch the attention. It also has a label, which is a security label on the pull request. You can see the change, 221 to 227. You can see the description. It tells people why they're getting it. It says this updates SPDX tools to avoid a critical vulnerability in Log4j. And there's a link to learn more. And just to confirm it, you can see there's embedded release notes. So the release notes actually do here happen to confirm that version 227 of SPDX tools updated Log4j to version 2.17.0. So that kind of closes the loop. So if you use Renovate, again, which is free, you use these remediation rules. If there's any straggling indirect vulnerabilities that you haven't fixed already, it'll help with that. And importantly, we keep updating this. So as that 24% of packages with fixes grows, we keep adding to the set of rules. So even if you install it today and maybe don't have any fixes, in a week's time, you might suddenly see a fix pop up and be happy to see that. Okay, so final bit is a customer case study. I mean, a lot of things went wrong for people in this. We had one customer, at least, that was extremely happy. So this customer is in the business of electronic healthcare record solutions. They, of course, don't want us to use their name. No one wants a target on their back. But you can imagine that if you're in the healthcare business, being exploited would be a very bad idea. And even literally the SEC and FTC in the US has been talking in the last week about companies being held, responsible by government for failing to remediate Log4j. So it goes beyond just being like a cost of business. Like, yeah, well, maybe we'll get fined and move on. The US government's trying to say, no, if you're in things like healthcare, you have to. There's no excuse. So this to give you an example, an indication, this customer scans 4,000 projects, 3 billion lines of code every week. I mean, they scan continuously, but this is the approximate weekly volume. There's bigger, of course, but this is pretty big. When you have thousands of projects, try to check them all out locally and determine if you've got like transitive vulnerabilities is not a great idea. Now, in this case, because they already had automated scanning, so because they already scanned their projects, and as I said before, we remember what they're using. They didn't need to rescan, they didn't need to recommit. They were immediately alerted. They knew which of their projects were affected, and they were actually able to remediate all affected libraries within 12 hours. And the quote that they gave us was, with WhiteSource, we're able to identify every touch point for Java that contained the vulnerability. We have a greater than 98% degree of certainty we caught every instance of Log4j. Frankly, that's the story of automation. Whatever your solution is, you really should automate it. You should be prepared so that you don't have to react and suddenly try and scan thousands of projects. Okay, takeaways and recommendations. I think I probably just said it, but open source vulnerabilities can hit at any time to any project. So WhiteSource, we're in the business of open source security. We would hit too. It's impossible to avoid. Like, unless you avoid all open source, I mean, you could have got lucky and not used Log4j for some reason, but the library you used instead could have had its own vulnerability next week. So realistically, it can hit anyone at any time. So you may not be able to prevent the vulnerabilities happening, but you can put processes in place to be better prepared. And the final point, automated detection and remediation will best position companies to be responsive towards future threats. So you can't stop them, but you can be prepared, you can be better positioned. And if you ever hear people talking about security posture, and it sounds like a bit of a silly term, it's not too silly, because that's really what we mean. That security posture is, are you ready for this? You know, are you on your feet? And automation is the way to achieve that. All right, so thank you very much. We've got a bunch of questions. I think Julio is going to come back and join us. Put the cameras on.
Yes, we did have questions. I do want just a quick reminder that if you do have a question, you can just head on over to the Q&A tab and to submit any questions you might have. First question here. Why were there so many CVEs for Log4j, and what was going on?
Do you want to take it, Sailor, or me?
I think I'll start, and you could continue from there. But the thing with Log4j is that it was a rolling event. It started back then with in December 10th, when it was first published with this is severe vulnerability. And then there was a fix that fixed it, but it wasn't enough. So moving on forward with more and more versions, eventually we ended up with having the last known major release, which was 2.17. And that's probably the latest stable one. I think that one of the root causes is that after such a vulnerability in such a scale found, so it attracts a lot of attention to it. And many people or researchers or experts that were not really interested in that before started to challenge the solution that might be solving that if and neither of us would ever known. But the fact that there was so much attention into it actually moved on to this rolling more and more CVEs and fixes, basically. Riz?
Yeah, I mean, it was a little bit like the horror movies where the zombie keeps coming back or something like that. People thought they had it fixed. With gosh, I mean, was it 2.15.0? I think was the first fix, wasn't it? And then there was like a new. Well, what it turned out was that the original fix didn't stop all the possible ways of leaking the string, into the JNDI. So then the next fix was essentially, getting that last 10%, and then because the focus was already on Log4j, then I'd call that maybe the copycat murders. Then there was sort of people thought, well, let's have some fun maybe and look into this more deeply, and people found some problems of lesser severity, which normally would not cause people just to work a weekend or something like that. Like I said, it's risk management, not risk removal. But because it was Log4j, it kept getting people's attention, and people kept saying, and in fact, within WhiteSource, we had this question because, of course, for the original Log4j with critical, we wanted to alert everybody. Like that's the type of thing where they say, thank you for waking me up, kind of thing. But then we say, well, here's the problem. The last one was like a medium, and we even thought it was a medium. It should be low. And you're like, we don't want to be, crying wolf, and making people again have to take action when it's not necessary. So it was a bit of a tough judgment call. But essentially, the first fix was not a full fix, and then there was 2 more cases where people found additional problems that weren't as severe, but because it was Log4j and people already had their attention, they kind of got a bit more attention than they normally would have.
And is this type of problem going to keep happening?
Yeah, so I kind of touched on that a little bit at the end. So in a lot of areas of security, you can have a goal of zero security, right? Zero security problems, right? So for example, secrets exposure, right? It's another form of security. Don't leak tokens, in a repository or things like that, or in logs. Now that's the type of thing where if you find that problem in your software, you would have a post-mortem and say, okay, how can we prevent that from happening again? Like, what extra checks and balances do we need to add earlier to get to zero? Like, only zero is acceptable, right? Open source security, unfortunately, doesn't have that. Like I said, the only way to avoid this one is like never to log or never to use open source or things like that. Like, realistically, there are no realistic alternatives that mean that you can avoid this in the future. We can't go back and do postmortems like WhiteSource. We can't say, hey, that's embarrassing. We're in open source security and we had a Log4J vulnerability. No, that's what happens when you use any open source. So the bad news, I guess, is to say that yes, these problems will keep occurring. Hopefully not something as big as Log4j, but if you use open source, vulnerabilities will be found in open source, and they likely will be found in dependencies you use in production. So being prepared is necessary. It's like, I don't know, it's like trying to stop an earthquake. You can be prepared, you can't stop earthquakes. So we can't stop open source security. You need to be prepared.
And I would like also to add that you said it's a bad news that we will keep finding vulnerabilities, but actually keeping finding vulnerabilities is an evidence of a stronger community of researchers that go and research and look into those packages. I mean, packages that are not interesting, we don't know about vulnerabilities. There has no vulnerabilities. I mean, of course, they do have vulnerabilities, but it's just not exposed because it's not being researched. So as much as the community of researchers and white hats and the security people that keep the open source actually safe is active, then we will keep seeing those vulnerabilities. And yeah, it's a good sign, and we want to be prepared.
Yeah, actually, that's a great point. We have seen a maturing of the vulnerability industry as well. So what you may have noticed is that, first of all, this problem was like responsibly disclosed to the Apache Foundation, and that when it was disclosed, there was like a fix available. Now, there were some leaks of it beforehand, but essentially, that a fix was available early. In the old days, that wasn't the case. I mean, there was this concept where, problems with no fixes were out there. Whereas in this case, it was like, okay, it's Log4j, update it. There is an actionable thing to do.
Riz, there is another session coming about the same thing in the NPM, right? I mean, how in NPM most of the vulnerabilities are published when there's already a fix.
Yeah, we found that in I think it was in 2021 that something like 84% of vulnerabilities when they were released to NVD already had a fix available. So that's pretty massive. Because in the old days, you'd say, oh, there's a problem, and you need to go we call it like monkey patching. You need to like apply patches. You need to go into the code and delete lines, comment out lines, change lines, try to essentially like mitigate it. Whereas today, in the majority of cases, thankfully, the recommendation is update. And that's also why, by the way, automated remediation becomes more powerful, because every time there's every time there's a fixed version available, it means that an automated approach will be much faster than a human approach.
Excellent. Well, unfortunately, we're just about at the top of the hour, so I do want to remind everybody that today's webinar has been recorded. So if you miss any or all of the webinar, you'll be able to watch it again. We will be sending an email with a link to access the webinar, and you can also find it on devops.com. Just look in the on-demand section in the webinars page, and it should be there. I did mention at the beginning that we were doing a drawing for 4 $25 Amazon gift cards, so I'll go ahead and announce the winners. Our first winner today is Peggy P. Congratulations, Peggy. Our second winner is Karsten W. Congratulations. Our third winner is Emiliano C. And our final winner is Betty W. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, please check your spam folder. Reese and Sayla, thank you very much for taking the time to put this presentation together. Judging from the chat, it was great. I'm sure it was really comprehensive, and we really all appreciate you all taking your time. out of your day to present.
Thanks, Julio,
Thank you very
and thanks
much.
everyone who participated.
It was a pleasure being here.
Excellent. I'd also like to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Take care, everyone.
Bye.